Hello, and welcome to Astronomy Daily, your premier source for the latest developments across the vast frontier of space and astronomy news. I'm Anna, your guide through the cosmos today, as we journey through some truly remarkable stories that have emerged in recent weeks. From the mysterious origins of life hidden within meteoroids that never reach our planet, to a significant leadership change aboard the International Space Station, we have a stellar lineup of stories to explore together. We'll also examine a ghostly galaxy that's challenging our understanding of dark matter. Consider how nuclear propulsion might one day take humans to Saturn's intriguing moon Titan, and wade into a surprising controversy about what truly makes someone an astronaut. So, settle in as we prepare to launch into today's cosmic discoveries and debates that are shaping our understanding of the universe around us. A fascinating new study has potentially solved a long-standing mystery in planetary science: why meteoroids that are most likely to contain the building blocks of life so rarely make it to Earth's surface. For decades, scientists have been puzzled by this discrepancy. Models suggest that over half of all meteoroids in our solar system are carbon-rich, yet these carbonaceous meteorites make up only about 4% of what we find on the ground. These carbon-rich meteorites are particularly valuable to scientists because they contain water, organic molecules, and even amino acids, potentially crucial ingredients for the emergence of life on early Earth. But their scarcity in our meteorite collections has left us with an incomplete picture of what's actually out there in space and how life's building blocks may have arrived on our planet. After analyzing nearly 8,500 fireball events from 39 countries, researchers now believe they've identified a two-step filtering process that explains this mystery. First, many carbonaceous meteoroids are essentially destroyed before they ever reach Earth. As their orbits bring them close to the sun, they experience extreme thermal stress from repeated heating and cooling cycles, which weakens the material and causes it to break apart in space. Then comes the second filter: Earth's atmosphere. Any carbon-rich meteoroids already weakened by solar heating are far less likely to survive the intense forces of atmospheric entry. The data shows that compact, high-strength meteoroids that have been baked in orbit have a much better chance of surviving and landing intact on Earth's surface. Lead author Patrick Schober, an astronomer at the Paris Observatory, explains that this filtering process means what we recover on Earth is not representative of what's actually out there in space. Some meteoroids are especially fragile, particularly those formed when large asteroids pass close to planets and are torn apart by tidal forces. The implications of these findings extend beyond mere statistics. If most carbon-rich meteoroids are being destroyed before reaching the ground, we may be missing crucial pieces of the puzzle regarding how water, volatiles, and amino acids, key ingredients for life, arrived on early Earth. This research could also influence future space missions targeting asteroids, especially those involving sample return. Understanding what gets filtered out and why is key to reconstructing our solar system's history and the conditions that made life possible. It also has relevance for planetary defense, since understanding the fragility of different types of meteoroids helps refine models for assessing potential threats from space. Thanks to worldwide fireball networks and large-scale observational data, researchers are beginning to fill in these gaps, revealing how cosmic forces shape not just our skies, but perhaps even the very origins of life itself. In a symbolic ceremony aboard the International Space Station earlier this week, Russian cosmonaut Alexei Ovchinin transferred command to Japanese astronaut Takuya Onishi, marking a significant moment in space diplomacy and cooperation. "Take care of our station," Ovchinin told Onishi as he handed over the symbolic key to the ISS. "It's our everything." The heartfelt sentiment underscores the deep connection astronauts develop with the orbiting laboratory that serves as their home during long-duration missions. Onishi responded with equal reverence, saying, "It's a great honor for me to accept the command of the ISS, and I feel so special that I am taking over the command from you." After his brief remarks, the two men embraced, while the rest of the crew applauded the transition. This handover ceremony represents one of the final orbital events for Ovchinin, who, alongside fellow cosmonaut Ivan Wagner and NASA astronaut Don Pettit, has been aboard the station since September 11th of last year. The trio is scheduled to depart the station tomorrow at 5:57 p.m. Eastern Time. Their undocking will officially mark the end of Expedition 72, commanded by Ovchinin, and the beginning of Expedition 73 under Onishi's leadership. If all proceeds according to plan, the Soyuz spacecraft carrying the 3 returning crew members will touch down on the steppe of Kazakhstan at approximately 9:20 p.m. Eastern Time. This moment highlights the ongoing international collaboration that has defined the ISS program for over 2 decades. Despite geopolitical tensions on Earth, the space station continues to serve as a remarkable example of how nations can work together in the pursuit of scientific advancement and space exploration. The leadership transition from a Russian cosmonaut to a Japanese astronaut also represents the diverse international partnership that maintains and operates the ISS, with participation from the United States, Russia, Japan, Europe, and Canada continuing to demonstrate that space remains a domain where cooperation transcends earthly boundaries. You probably know we love a good mystery here on Astronomy Daily. Well, here's today's. Astronomers have stumbled upon yet another cosmic oddity that's challenging our fundamental understanding of the universe. A ghostly galaxy, designated FCC 224, appears to be missing something crucial: dark matter. This peculiar finding is leaving scientists scratching their heads. Dark matter, that invisible substance thought to make up roughly 85% of all matter in the universe, provides the gravitational scaffolding that allows galaxies to form and grow. Finding a galaxy without it is like discovering a shadow, without an object casting it. It simply shouldn't exist according to our current understanding of cosmic formation. FCC 224 isn't the first of these mysterious objects, but it's adding important pieces to an increasingly complex puzzle. Located on the fringes of the Fornax cluster, about 65 million light-years from Earth, this dwarf galaxy possesses a dozen luminous, tightly bound star clusters, an unusually rich population for its modest size. Maria Buzzo, a doctoral candidate at Swinburne University of Technology who led one of the studies on this enigmatic object, puts it bluntly: no existing galaxy formation model within our standard cosmological paradigm can currently explain how this galaxy came to be. Her team used data from the Keck Observatory in Hawaii to track the movement of star clusters within FCC 224. What they found was revealing. These clusters move surprisingly slowly, a telltale sign that the galaxy lacks the strong gravitational pull that would be expected if dark matter were present. What makes this discovery particularly intriguing is that FCC 224 occupies a completely different cosmic neighborhood than other known dark matter-deficient galaxies. This suggests these ghostly objects might not be isolated anomalies, but could represent a previously unrecognized class of dwarf galaxies scattered throughout the universe. Another research team led by astronomer Yimeng Tang at the University of California, Santa Cruz, has proposed a potential explanation. They suggest FCC 224 could have formed from a high-velocity collision of gas-rich galaxies. In such a violent event, the gas would separate from the dark matter, with subsequent star formation occurring in the expelled gas, creating a dark matter-free galaxy. Tang's team believes FCC 224 likely has a twin galaxy, possibly the nearby FCC 240, which appears to have the same size, shape, and orientation. If confirmed, this would provide crucial evidence supporting the collision scenario. Alternatively, FCC 224 could result from a chaotic, high-energy environment where intense star formation from overmassive star clusters actually expelled dark matter from the galaxy, a process that challenges conventional astrophysical models. FCC 224 serves as a crucial data point in our effort to identify and study other dark matter-deficient galaxies, Buzzo explains. By expanding the sample size, we can refine our understanding of these rare galaxies and of the role of dark matter in dwarf galaxy formation. These ghost galaxies are forcing astronomers to reconsider long-held theories about galaxy formation and the nature of dark matter itself. As our observational technology improves and more examples are discovered, we may need to fundamentally rethink how galaxies can form and evolve in our universe. The mystery of FCC 224 reminds us that despite all we've learned about the cosmos, the universe still holds profound secrets waiting to be uncovered. Each anomalous discovery takes us one step closer to a more complete understanding of the cosmic tapestry that surrounds us. Next in today's story roster, Saturn's largest moon, Titan, has captivated scientists since the Pioneer 11 probe first gave us a close look in 1979. With each subsequent mission, from the Voyager probes to the Cassini-Huygens mission, the moon has only become more intriguing. Titan stands as the only celestial body besides Earth with a thick, nitrogen-rich atmosphere, and remarkably, it features a methanogenic cycle similar to Earth's water cycle. These unique characteristics, along with Titan's rich prebiotic environment and complex organic chemistry, have fueled speculation that life might exist there, possibly in the form of simple organisms dwelling within its vast methane lakes. This potential for discovery is what's driving NASA's development of the Dragonfly mission, a nuclear-powered quadcopter scheduled to begin exploring Titan's atmosphere and surface in 2034. But what about sending humans to this distant moon? According to a recent study by the nonprofit organization Explore Titan, a nuclear fission propulsion spacecraft could make the first crewed mission to the outer solar system a reality. The research, conducted by William O'Hara and Marcos Fernandez-Tous, was presented at the 56th Lunar Planetary Science Conference earlier this year. The challenge is formidable. While NASA has been working towards sending humans beyond low Earth orbit since 2005, the distance to Titan dwarfs anything we've attempted before. At approximately 8.5 astronomical units from Earth, compared to Mars at just 0.5 AU, transit times would need to be dramatically reduced to protect astronauts from extended exposure to microgravity and cosmic radiation. The researchers assessed several nuclear propulsion technologies that might make such a journey feasible. They examined NASA's nuclear thermal propulsion concept outlined in Design Reference Architecture 5.0, which describes a 56-ton crew-capable spacecraft using a uranium-235 reactor and hydrogen propellant. While this system could complete a Mars mission in about 375 days, the much longer duration required for a Titan mission would pose significant health risks for the crew. They also evaluated Copernicus, a larger nuclear thermal concept proposed in 2013 that could potentially reduce one-way transit times to between 150 and 220 days. Even more promising is the Variable Specific Impulse Magnetoplasma Rocket, VASIMAR concept, which relies on a nuclear magneto-hydrodynamic reactor to power an electric thruster. According to one study, this technology could reduce transit time to just 149 days. Perhaps most intriguing is the direct fusion drive concept, which a 2020 study suggested could enable a robotic mission to Titan with a round-trip time of 2 to 2.6 years. Properly adapted for human spaceflight, this technology could make a crewed mission to Titan viable. Explore Titan proposes extending NASA's current Moon-to-Mars approach to include Titan as the next logical destination. Their vision is a Mars-to-Titan progression, where technology developed for human missions to Mars could be evolved for exploring Saturn's mysterious moon. The researchers concluded that nuclear space propulsion systems may be the key enabler for future Titan missions. Given the health risks associated with deep space human spaceflight, advanced propulsion could be the most critical element to their success. While such missions remain years away, the work being done today lays crucial groundwork for what could become humanity's most ambitious journey yet, extending our reach to the mysterious, methane-rich world that might harbor the ingredients for alien life. Finally, today, let's turn our attention to a controversy that's come into focus this week. A recent suborbital flight aboard Blue Origin's New Shepard spacecraft has ignited a surprising controversy in the space community. The mission, designated NS-31, featured an all-female crew, headlined by pop superstar Katy Perry, along with Jeff Bezos' fiancée, Lauren Sanchez, and 4 other women. The flight generated extensive media coverage, from tabloids to serious news outlets, celebrating this milestone for women in space. However, it also revived a debate that has simmered since the early days of commercial spaceflight, namely, who deserves to be called an astronaut? The controversy took an unexpected turn when U.S. Transportation Secretary Sean Duffy weighed in on social media, stating, "The crew who flew to space this week on an automated flight by Blue Origin were brave and glam, but you cannot identify as an astronaut. They do not meet the FAA astronaut criteria." Duffy referenced previous Federal Aviation Administration guidelines under the Commercial Space Astronaut Wings program, which specified that crew members must have demonstrated activities during flight that were essential to public safety or contributed to human spaceflight safety to qualify as astronauts. This statement raised eyebrows because the FAA, which falls under Duffy's Department of Transportation, had previously stated it would no longer designate anyone as an astronaut. In fact, the agency's human spaceflight page explicitly says, the FAA no longer designates anyone as an astronaut. In addition, the FAA does not define where space begins. The apparent contradiction highlights the evolving nature of human spaceflight in this new commercial era. The FAA's Astronaut Wings program, created in 2004 to recognize the pilots of Spaceship One, was discontinued in December 2021. The agency announced that starting in 2022, it would simply list individuals who reached 50 statute miles above Earth on its website, rather than issuing formal astronaut wings. Some space enthusiasts and industry observers have expressed concern that flights like NS-31 trivialize the serious work of commercial spaceflight. While acknowledging the historic nature of an all-female crew, critics suggest the celebrity-driven spectacle reinforces the billionaire joyrides perception that has dogged private spaceflight since Branson and Bezos took their own suborbital trips in 2021. Others counter that these high-profile flights generate valuable public interest in space exploration and help normalize the concept of civilian space travel, a necessary step toward humanity becoming a truly spacefaring civilization. The debate touches on fundamental questions about the democratization of space. As access to space expands beyond traditional government astronauts, perhaps it's time to reconsider what being an astronaut means in this new era, or whether the term itself needs to evolve along with the industry. And with that, we wrap up our cosmic journey for today. From mysterious meteoroids carrying life's building blocks to ghostly galaxies defying our understanding of dark matter, from leadership changes aboard the International Space Station to the potential for nuclear-powered exploration of Titan, and even the surprising controversy over what makes someone an astronaut, the universe never ceases to amaze and challenge us. I'm Anna, and I've been your host for this edition of Astronomy Daily. Thank you for joining me as we explored these fascinating developments at the frontiers of space science and exploration. If you're hungry for more space news, visit our website at astronomydaily.io, where we maintain a constantly updating newsfeed of the latest discoveries and missions. You'll also find our complete archive of past episodes there. Don't forget to connect with us across social media. Just search for Astro Daily Pod on Facebook, X, YouTube Music, Tumblr, Instagram, and TikTok. Until next time, keep looking up and wondering about our extraordinary cosmos. This has been Astronomy Daily.